Greetings, everyone. Thank you for joining us at Exchanging Ideas 62. A warm welcome to the speakers around the globe. Thank you for joining us. And to the audience, please click subscribe button on top of this YouTube channel. I'm Kaneshwaran Goindasamy, and I will be moderating this event. Please watch at the end. We'll have a favorite, fantastic debate on how telecoms are reshaping mobility. And today's topic that I would like to present is that as a third party, just 1 second. As a third party, I will be giving my point of view on Qualcomm's presentation this year. And the topic that I'll be presenting is driving the digital future of automotive. Snapdragon technology provides the main building blocks for smart software-driven cars, which highlights the different Snapdragon solutions like cockpit, car to cloud, auto creativity, and ride that work together to make vehicles more intelligent, connected, and easier to update with new features. Now, the new technology is making the inside of cars more comfortable, fun, and connected, and features like smart screens, voice controls, and fast internet, which let passengers enjoy music, movies, and helpful apps while traveling. Now, cameras are placed around the car, like the front, back, and sides to watch for other cars, peoples, and obstacles. The car uses maps and can talk to other vehicles and the road to get more information. And all these tools work together to build a smart, automated driving experience that makes the car more aware of its surroundings and better at making safe decisions on the road. Now, this shows cars surrounded by icons representing things like the vehicle can identify, such as bikes, emergency vehicles, commercial vehicles, cars, two-wheelers, traffic lights, pedestrians, and EV charging stations. The car uses sensors and cameras to see these objects and make decisions automatically, creating a safer and more efficient driving experiences without human intervention. Um, Now, making cars smarter and more digital involves many layers of technology working together. At the bottom are the car's computers chip, the SoC, and above there are different types of software, including the car's operating system, special programs like middleware, and apps that people use. All of this connects to a powerful cloud services, which help keep everything updated and running smoothly. Qualcomm's automotive advancements integrate sophisticated software architectures for central compute that enables mixed criticality and safety virtualization, allowing multiple systems to efficiently run on a shared hardware. And the foundation concept of SDV underpins that digital chassis solutions, while the increasing integration of both edge and cloud-based AI is emphasized across the entire automotive portfolio and tool chains. The digital chassis into four key pillars, each powered by Snapdragon. Cockpit manages in-car experiences like instruments, clusters, navigation, cameras, displays, and audio. Snapdragon Car Cloud facilitates services, platforms, and maps. Snapdragon Ride covers scalable ADAS and ADSOC portfolio. And Snapdragon Ride Vision and automated driving stacks and sensor partnerships. And lastly, Snapdragon Auto Connectivity, which ensures robust 4G, 5G cellular connectivity, in-car connectivity, positioning, EV charging, and V2X communication. Now, this shows Qualcomm Orion CPU and Adreno GPU with a hexagon NPU acting as the brain. And this brain concepts two different types of AI models, the LMM multimodal for handling various data types, the LLM language for understanding speech, and LVM vision for processing visual information from cameras and sensors. All these components work together to power interactive displays and features within the vehicle. A 3 times increase in GPU performance for better graphics, a 12 times increase in NPU performance for advanced AI capabilities, support for up to 16 high resolution displays, a 4 times increase in audio DSP for superior sound that is being offered by Snapdragon Cockpit Elite. These layers from platform software and middleware to car OS, Qualcomm AI stack, ADAS services, and in-vehicle infotainment represent the software that defines the vehicle functions. All of these connected to a cloud infrastructure via Snapdragon car to cloud, enabling seamless data flow and services. Now, this AI acts as the central brain of a car, connecting various aspects of a user's digital life, in-cabin experiences, and the environment around the vehicle. The AI processes information from personal devices, monitors the car interior like passengers and objects, and perceives its surrounding using sensors. And this integrated AI then enables the car to perform smart actions such as automatically opening the sunroof based on user preference and weather, dropping off passengers and parking itself when near a destination, or rerouting to avoid traffic and emergency vehicles. And how developers can utilize the Qualcomm AI Hub, which provides a model library and validation tools along with the Qualcomm AI stack for direct AI engine control and generative AI extensions. These development tools and AI capabilities connect to the Snapdragon digital chassis, workbench, and cloud platform, which then enables the creation and deployment of automotive applications within the vehicle. Essentially, Qualcomm provides complete ecosystem for car manufacturers and developers to build, test, and integrate advanced AI features into intelligent vehicles. And last slide, Qualcomm partnered with Chinese firm Datang Telecom Group for a multi-chipset vendor C-V2X direct communication interoperability demonstration in China. Datang Telecom Group is a major Chinese telecom operator. In the US, Qualcomm collaborated with Indra and Audi, the part of Volkswagen Group, on a project demonstrating C-V2X tolling technology, but this involved automotive and technology companies rather than a mobile network operator per se. Qualcomm also worked with Geely and Gosang in China for mass-produced 5G and C-V2X enabled vehicles, where Gosang is a telecom and network operator supporting this deployment. Qualcomm's ecosystem includes partnership with automobile OEMs like Audi and Ford, but no specific mobile network operator is named in the US context for the C-V2X. I think that's about my presentation. And just 1 second, let me stop sharing. And I would like to introduce our next speaker, Sharik Khan from Paris, France, to present on vehicle connectivity and mobility. Sharik, I can't hear you. I can't hear you. Or do you want to use without the microphone, without your earphones?
Hello.
Yes, yes, it works.
Yep. So, really, apologies. I don't know what happened. Everything was pretty fine. So, good morning, good afternoon, everyone. Thank you, Kanesh. So, my name is Sharik, and I'm based out of Paris, and I have almost like 2 decades of experience, starting from telecom, automotive, and semiconductors. And today, allow me to share my screen. I think I'll focus on the topic of vehicle connectivity and mobility. So can you see my screen?
Yes.
Okay, so let me make it a full screen. Not here, but right. Uh, is it full screen yet or not yet?
No.
Okay, I don't know what's wrong. Even I enabled the second screen. Please. I don't know. I do not. Okay, maybe I could. Is it? Is it? Is it? Can you see the screen?
Yes, yes.
Can I?
Please continue.
Okay, so let me focus on the topic, and apologies. I have a problem with two screens right now, and I could not resolve it. Even I tried, but I guess I need to restart the computer. Perhaps it's not a good solution now. So, so to summarize today, what we see, I mean, from where the vehicle have started today, from full mechanical cars, today we are having cars with a number of sensors, huge computing, connectivities, the jugular vein of every functionality from ADAS, for multi-sensor, onboard, off-board, OTA, everything. So we see that today the vehicle is once manufactured and it's connected for all the lifetime. Offline doesn't exist, whether it's in parking, whether it's in different modes of transportation, or in all the time vehicles are connected throughout the life. We see the rise of connected vehicle, which requires real-time data exchange, traffic safety, infotainment, requiring high bandwidth, latency, low latency for critical applications, even 24 by 7 connectivity. However, one of the major factor today is we do not have a proper homogeneous connectivity for vehicles. Unlike smartphones, a vehicle goes to -4 parking. Vehicles are normally most of the time in different scenarios like crossing borders and many critical functions which requires all the time, especially on ADAS or on infotainment, on navigation, lane change. These requires critical information all the time, unlike smartphones. So the point is that vehicle requires continuous and constant connectivity all the time, which is not the case today. Today we have some holes in terms of terrestrial network coverage. That means the penetration of connectivity is not everywhere, and this is a big drawback today for connected cars. So, is 5G terrestrial network enough to overcome this? Perhaps no. So today, as we see that we are moving towards 5G release 15, 16, 17, and 18, 19 still under ongoing, not yet completed. So what we see today is from release 17 onwards, with the addition of NTN, non-terrestrial network, which is complementing 5G terrestrial network. That means all the coverage gaps what terrestrial network provide. So 5G NTN is trying to complement and overcome those intermediate connectivity by two means. So NTN has two segments. One is IoT or narrowband NTN. Another one is NR NTN. So IoT is basically focused on non-real-time communication for small SMS or just some alerts with a very low data rate, whereas NR is a solution with high data and bandwidth, a substitute to today the cellular connectivity on terrestrial network. So that's the part of NTN, and so NTN is one of the potential solution which can overcome those gaps and provide seamless connectivity to all the vehicles. Now, NTN is a part of stranded 3GPP. That means it is a big ecosystem worldwide, and it could integrate the interoperability as well as it can also evolve towards 6G with release 19 onward. I mean 21, release 20 and 21, which is towards 6G. So it has a huge potential to move forward and overcome the point of connectivity. So what are the challenges basically when we talk about mobility? So one is, like I just mentioned, connectivity. So NTN will complement what today is not 100% homogeneous connectivity, whether -4 parking or crossing borders or mountains like Mont Blanc, where we are traveling for vacations. But the other part is in terms of global coverage. So in terms of, because vehicle is mobile all the time with a high speed or low speed in different environment like urban or rural environment. So main challenges were global coverage. So NTN plus TN is one of the potential solution to provide a seamless handover so that we all the vehicles remains connected globally on the remote areas as well as on the highways as well as crossing borders. Number two is in terms of redundancy and resilience. So in term, for example, I've been to Japan and I realized that during tsunami, all the cell towers which are based on terrestrial network doesn't work. And I think that's one of the potential use case what I realized which NTN can resolve. So during those time, there's no communication. So all the cars in that case perhaps can use NTN can act like a backup to terrestrial network. So that's where the part of resilience and also redundancy come into picture. So in terms of natural disaster, which I see NTN can add to the mobility and complete end-to-end connectivity. Third is mission critical application. So I think that's again one of the important part when you talk about safety. Safety in terms of also when we sharing of sensor information within cars, and we see that everywhere we do not have direct communication or even cellular communication, or even from from the part of infrastructure we don't have. In that case, NTN can complement. When I say NTN, that means from LEO, MEO, and GEO, all the three layers included, as we see that network deployment. And LEO is quite close to the Earth's surface, around 260 kilometers in line of sight, precisely. So this provides an alternative solution with different traffic models to secure the communication. And the last and the very important part is regulatory and standard support. So today, as I just explained, that really 17 defines NTN, narrowband, as well as NR. And we see this is the seamless integration and standardized operation moving forward. So this 18, 19, and forward. So that's one of the potential very strong momentum which we see in automotive today. So if I try to summarize and explain about vehicle ubiquitous connectivity, which includes terrestrial as well as non-terrestrial network. So number one is that 5G and 5G Advanced is transforming vehicle connectivity with higher bandwidth, potential use cases of low uh, latency. NTN is complementing where 5G and extending the range and where 5G is not reachable. So both of the technology is like proper handover between these two, where we do not have TN, we can have NTN, and this makes for the end user experience, he doesn't feel when he shift from TN or NTN. So that's the service layer continuity, what end user requires, who is using the car for any function, whether it's a real time or non real time function.
Sharik, sorry, your time is over. Would you mind to quickly wrap, please?
Yeah, I'm just writing it. So, second part is about so we see AI-based routing, which is I think quite imminent these days, which is also a part which helps to switch between TN and NTN accordingly, not to abuse the NTN network. And we see so to summarize, ubiquitous connectivity is the way forward for true global mobility and reliable communication. Thank you.
That was fantastic presentation. Thank you so much, Really appreciate that, Sharik. And for some of the speakers who have switched on your cam, please switch off your cameras so that we will save the bandwidth. Um, and only the speaker just need to switch on the camera during the presentation. Thank you so much. Let me introduce our next speaker, Marcelo Wach from Wolfsburg, Germany, to present on autonomous ambitions, which nation will dominate the robot taxi market. Over to you.
Hi, hello everyone. So thanks a lot for the time. I would like to quickly start. And before I start, I would like to kindly ask you guys, because it's a really simple question. Everyone has your own opinion. And if it's okay, you can scan this QR code and fill a quick poll with one question, just not a boring question. And the question is, which nation has the best chance to dominate the future of autonomous vehicles? I think this is a really important question because autonomous industry is not just one industry. I believe that this is the new kind of space room that the countries are trying to achieve the moon first, and this evolves and this needs not just one side but the whole society to achieve this target. And to be not so boring and somehow interesting, I try to create some comparative analysis which the main countries that should represent some advances on this field. And on this direction, I would like to present for you guys what I call the AFAL race framework. So basically, every transformations, you need to have ambition. And to have this national ambition, we need to create or embrace just all the sectors of the society, not just one side, but I split this in three different pillars. That is the industry, that is the populational, and that is the public pillar. I will go deep dive in each one of these pillars further, but I would like to explain what is societal acceptance here, because to achieve this technology, not just one technology trend, but you have to achieve economy of sustainable and advantage for the whole society level, not just for industry, but the whole public. And to achieve this, it's important to fill the gaps in all this pillar, and the country that fill these gaps will have the more chance to succeed. And let's just directly start on these pillars to talk about this each one of these pillars. And the first one that I called populational pillar, it's englobed here the traffic culture and the criminality. So the traffic culture is clear how dangerous is the traffic in the country. Just a short information, I lived in Germany around 10 years, and I already lived also 2 years in China. So I have the opportunity to evaluate with my own eyes the traffic culture in these three countries. I never been in US, but I talked with some colleagues to get this, to have these feelings. And not just, but I took also some statistics. So there is a World Bank that they bring some statistics, and this just confirmed my feeling, and you guys has your own feeling also, that Germany is on this top the benchmark with a really low level of death for 10,000 vehicles. And just is not even better because they have no limits on the autobahn. That is a kind of challenge for the technology. And there is some accidents, critical accident that happens due to this lack of speed limit. But even on this situation, Germany it's at the benchmark on this. US is a middle, and this is for sure the pain point in China because they have a really dense traffic situation, a lot of vulnerable road users VRUs that runs on the streets, mopeds, and this poses a really challenge for the China in this direction to achieve this. The other pillar on this populational pillar is the criminality. So this is a critical point because, as you know, it's really hard to change the safety or the criminality in one country. And we see that China is really safe country. It's incredible how you feel safe there. There's a really strong police presence. It's a surveillance. It's really presence also there. But this brings the position on number one for China advantage. In Germany, it's also a safe country. And one topic of this criminality that you'd like to talk, it's the vandalism. As we see, as you guys probably can see in the social media yesterday, or there is some case of vandalism against the Waymo vehicles. And this is a really challenge because each prototype costs a lot of money and no one can just waste this money and burn this on fire when there is some kind of revolt from the population. And this brings a pain point for US here, and that is the criminality. And this index I took also from one website that they bring this safety feeling survey. It's a really interesting. And they also just show this index level for each country. So let's go for the next pillar. The next pillar is again, it's institutional pillar, and that englobes the tech investment and also the educational investment, basically. And at the tech investment, I see at least the US as a front end because they have the Silicon Valley innovation ecosystem that's a really strong NASDAQ, and they have a lot of tools to collect and to found in this technology. We already have some companies in this area like Waymo, Tesla. Cruise was closed, but they also found a lot of money to invest on this technology. The second position is from China. They have a massive state lead support. They invest a lot in autonomous vehicles and also AI. AI is not the same industry, but they both run really close together and one for sure help each other. They have a strong integration with the system, the cities, and they have also private companies like Baidu, Xiaoping, Xiaomi, and many others that invest massive amounts of money on these fields. Here is a pain point for German that they have some challenge to found in this industry. They have some big companies like Volkswagen, BMW, and Mercedes Group, but they are not, let's say, having any kind of founding support from the society or from the government to achieve this target. And educational, also I put here the number of teams graduates per year. We know that China is in the front on this field. It's now, for example, there's one interview from the Apple CEO that he said, so in US, I can fulfill a room with engineers, with high-skilled engineers. In China, I can fulfill a stadium with engineers. So they have advantage on this area. US still have some world-class universities. They have a really strong institutional students. It's somehow a challenge now with this new immigration policy that push some pressure because they are not being able to attract the better high-skilled engineers at this moment. A lot of afraid with the political situation, and this brings some uncertainty in the future of this US future regarding this educational or the high-skilled engineers to attract to the country. And German, again, is the last here in this position because they have a lack of engineers since a long time. They are fighting with this. They are trying to attract high-skilled professionals from all the country and other areas. Also, they have some gaps, but they still having a good position compared with the whole globe. They have a good university, and they just need to focus and to bring software expertise in this country. That is a huge challenge. And the last pillar is the government pillar. What depends most strictly from the government. Somehow the society, the industry can also help, but I see as a main responsibility of the government. As you guys talk in the last presentation, Kanesh and Sharik told, like there is a lot of needs for this industry. Like 5G, it's one basic infrastructure that we need to be able to bring this technology. So China, it's investing roots, a lot of money. They are putting this as a priority in the country. So they have a root, and they have many areas that they are already being able to test, not just ODD fence or a geofence, but the whole some cities that they offer this possibility to start the first AV testing operation on in the cities. And the second, US has also some areas, as well known, Waymo in Phoenix and San Francisco. But again, this is some really, really small areas in the whole country. They still need to involve and to achieve the whole coverage in the country. They have a long way forwards. Also here, German regarding infrastructure, they have a really good infrastructure from autobahns, but they still have challenges regarding the telecom infrastructure. There is a lot of gaps, and the 5G availability, it's really the lowest level in comparison with other countries. And this shows that the German has to put a lot of money, invest a lot of money on this infrastructure to be able to deploy this technology as a country level. And the last that I put here is a legislation that it's like, again, to give a framework that it's safe and that has a legal framework. It's also important for the industry. And Germany has already the first legislation deployed, and they are also a front end in this field. China, after this Xiaomi accident, so happens a Xiaomi accident some months ago in China, and they decided took a really revolution on this area. They are bringing up a lot of new regulations that will push forward the legislation of AV in all the globe, and they are coming with this Chinese speech on this area, and probably they will pass the whole country in the future soon. And the last is the US, that they have a decentralized approach. Each state has different rules, and this brings a lot of complexity and makes this really hard to achieve this country coverage level of one unique policy. And this is a challenge for the US situation. Just to finish now, that we have just some minutes. This is my
Marcelo, your time is over. Sorry.
Yeah. Just to finish. This is the conclusion. This is the last slide, and this shows that at the first position we have China, that has the front on this area, that they have one advantage. The maximum index is 150 based on these evaluations, and then after comes US, and the last German. Thanks. This is my conclusion. Thank you.
Thank you, Marcelo. Fantastic. Appreciate that. Let me introduce our next speaker, Dr. Mali Saad from Seoul, South Korea, to present on cellular connectivity for the vehicles, focusing on resource allocation challenges in new radio V2X. Over to you. Mali, I can't hear you.
Okay. Thank you for arranging this session, and I'm going to talk about on cellular connectivity for vehicles while focusing on resource allocation part, and I will discuss some challenges in cellular V2X technology. Okay, just to give an overview about what is V2X. V2X like vehicle to everything, and here we are talking about the connectivity of vehicles to everything. So with the V2X, that includes V2I, vehicle to infrastructure, vehicle to networks, vehicle to vehicle, and vehicle to pedestrians. And nowadays, there are many groups which are working towards in order to support the V2X communications and to protect the vulnerable road users as well. And I will discuss about the V2B communications part, and I will discuss about some challenges regarding the resource allocation part for V2X communications. And to understand why we are talking about V2V and why we need V2V. And if I talk about, and in the last presentations, the presenters had talked about the autonomous vehicles as well. But if I mention, if we have to notice one thing, for autonomous vehicles that rely on lidar and radar technology, It's like they can provide us some convenience in having driving the vehicles in the automation. But in terms of if we talk about like the V2V communications, it's like we can see what our eyes cannot see. And if we talk about just the radar or lidar technology, it's just like the radar and lidar can detect what our eyes can see. But based on V2V communications, it's like we can support 360-degree awareness. So that's why if you can see from this slide from the left, we can see like based on the V2V communication technology, we can know what is in front of the bus. So the motto behind to enable V2V communication is to enhance the safety for the pedestrians, for the drivers, and for the road users as well. While there are like two big groups that supports vehicular communication standards. One is from the IEEE and one is from the 3GPP, which is from the Europe, and IEEE is from the American based standard. And I will discuss about the cellular technology as well. So cellular technology, 3GPP is have enabled the cellular technology, which is C-V2X cellular vehicle to everything. And this is the roadmap you can see from the slide. And here we have some progress for the IEEE based technology, which relies on the Wi-Fi based technology. And from the 3GPP, we have the cellular standard. And now we are in the era of like release 18, which is also coined as 5G advanced V2X. Just like in 4G, we have like LTE, and now for we are moving towards 6G, but now we are in an era of like 5G advanced. And here we are in release 18. And also now all the many industries now they have a unified consensus that we're gonna have only C-V2X technology, which is cellular technology, and NR-V2X is also in cellular technology. That is the evolution of C-V2X. Just in 5G advanced, it is named as new radio V2X, NR-V2X, and you can see that from the Federal Communication Commission, they have also announced the sunset time for the DSRC-based technology, which is from the IEEE, and now all the rules have been effective from 11th of February from 2025 for the C-V2X technology. And also they have set the sunset period for the DSRC-based technology, which is by 14th of December 2026. So this is from that we have a consensus that now we only have one technology for V2X communications, which is cellular technology, because it is backed by all the telco and industry groups. And so here I'm introducing about the NR-V2X technology, which is built on the cellular technology, which is the evolution of cellular technology, and now NR-V2X. Just like we have some new features, we have some NR numerologies at the physical layer. And also here we can see about from the spectrum. As in the cellular infrastructure, we have cells or we have zones. Same wise for in order to support V2X communications, we have different zones or regions, and we have spectrum distribution, and we can reuse the spectrum because we have a limited spectrum. This is just showing that we can reuse the spectrum. And if I talk about previously, we did have 75 megahertz for intelligent transportation systems. That includes the DSRC-based technology and as well as the cellular-based technology. And we have a 75 megahertz spectrum for that. And the bandwidth is like 5850 megahertz to 5925 megahertz. But based on the new rules from the FCC have announced that we're going to use the upper 30 megahertz specifically for the C-V2X, and the lower 45 megahertz will be allocated to the unlicensed use for Wi-Fi based technologies as well. So anyways, we can see that although it has been recognized that 30 megahertz explicitly for the C-V2X based technology, which is a good news for the industry as well, because they have officially recognized the spectrum for the V2X communications, but also it could be a bottleneck because we have only 30 megahertz, which is very limited. And here we're going to have some challenges for the V2X based communication. This is just an overview of the resource grid that we have resources over time over the two-dimensional like time and frequency domain. And this is showing an overview of the resource grid. And here I'm talking about like connect for the vehicles, they have to talk. And this shows that vehicles are talk. There are like two modes in which vehicles can communicate while selecting resources. So there are two modes are like mode 1 and mode 2. I'm going to talk about mode 2 because this is a decentralized method. The vehicles themselves select the resource from the resource pool to communicate. And if we talk about mode 1, the G node B or the base station have to allocate resources to the vehicles in order to talk. But this will adds up a lot of overhead. So we can, and because of the low latency communication for the safety purpose, we exchange the messages like speeds of the vehicle or direction or other things. So that's why we have to rely on this centralized mechanism for communication, but under the standards. So here we have like, I will talk about mode 2 communications, and in mode 2, the vehicles select the resources by themselves based on some semi-precision scheduling. So here, like 10 minutes are not that enough for me to wind it up all. So I will just give an overview about that we have semi-precision scheduling for this communication with the vehicles. Here we have some challenges. We can see that it's just like competition because the two vehicles cannot make sure that I'm going to select which resource and my resource will get overlapped with another vehicle. So this is a resource consensus problem and it will lead to resource contention. And we have, if the two vehicles select in the same time, the probability is very high because they sense the channel at the same time. And when they sense the channel at the same time, the probability of selecting the same resource is very, very high. So this will lead to resource collision, and at the end, we cannot talk to the other vehicles because our packet will be collided and performance will be degraded. So this is showing another aspect of hidden node problem in wireless technology that we have. So here you can see that this transmitting vehicle would like to talk with this receiving vehicle, but this vehicle is hidden node with respect to this transmitting vehicle. And if this vehicle have already occupied this resource, and this will lead to the packet collision, and this vehicle cannot able to talk with this receiving vehicle. So this is another problem that we can see. And what the vehicles exchange between them is a safety message, which is named as cooperative awareness messages. And I like to conclude about that these safety messages are not periodic; they are aperiodic. Like they depends upon some event like speed change or heading or change of like acceleration. So it depends upon such kind of events. So the message packet generation time is not, we can say it's periodic. And even though the size of message packet is not periodic, it depends upon the situation, like if we have a change of lane or if we have to report some accident. So we have some optional containers that will change the size of the message. So if we reserve the resource in periodic manner, it will lead to unutilized resources if we have some aperiodic message generation. So here you can see from this slide, let's suppose this vehicle have this message packet. Later on, it selects this one for the transmission and it reserves this one and it announces its reservation. It's just like you want to arrange a seminar and you book a room, but your guest don't appear on time. So it will lead to unutilized resource because we already announced that I'm gonna use this resource, but in real we are not using this resource because of some a generation of message packet, and we need to reserve a new resource, because here we just reserve the resource for, let's suppose, 200 bytes of message, and here we got like 455 bytes, so we cannot send those 455 bytes in the space of like 200 bytes. So this
Dr.
will lead
Malik,
to
sorry, your
unutilized
time is
resource.
over.
Yes, sure. I will wrap it up in like one minute. So here you see that we also have some resource issue with the latency of the message packet, and also you can see that we have some other challenges with the message interval time. So these are the three cases. So these are the summary of research challenges that we have. And this is some of our ongoing work that we are trying to predict the CAM packet and to select the resources accordingly. And this is, I have put the references of some of the work for some technical reports and some of our journal papers. We mentioned about how we can achieve distributive resource selection while avoiding resource conflict. This is some of our ongoing work, and we did some on-road testing. You can see we just have a demonstration on this slide. And here I just talk about the on-road deployment of V2X. We have some collaborations with our international partners and universities that we are working on the V2X project. Yeah.
Awesome. Thank you, Dr. Mali. I appreciate that. I would like to introduce our next speaker, Derek Moser from Zurich, Switzerland, to present the importance of 5G standalone roaming for the future of vehicle connectivity.
Yes, thank you, Karnesh. Very interesting indeed. The presentations so far. Sharing my screen now. Can you see it?
Yes.
And in presentation mode. So how's that? Can you see this?
Are you able to make it? Are you able to make it a full slide?
Yes.
Okay.
Is that better?
Yes, sir.
Okay, perfect. Thank you very much. Very interesting indeed, the presentation so far. I represent Comphone. We do wholesale mobile roaming. We enable all MNOs, MVNOs, CSPs, including satellite providers of all sorts to set up, establish, and maintain and manage their roaming, international roaming services. So I'm new to the vehicle connectivity space. It's been a fascinating journey so far. Thank you very much. So as we've heard in the previous discussions and presentations, connectivity is key. And it seems cellular connectivity, cellular technology is best suited to provide ubiquitous connectivity to vehicles. So with modern connected car technology, we're close to reaching the reality of our vehicles updating themselves mid-journey, dodging traffic in real time, and talking to smart traffic lights, talking to each other, all while crossing borders. So as we move towards 5G standalone, so these scenarios are becoming a reality, actually. So from an evolution perspective, as we know, remember 2G gave us emergency calls. 3G started to give us data, some real-time tracking, some basic telematics, and 4G finally gave us some faster data infotainment and even OTA updates. And now we're moving towards 5G autonomous driving, V2X, as we've seen in previous presentations, real-time services. So 5G standalone really changes the game with latency and real-time communication, and our cars becoming, vehicles are becoming cloud-connected edge devices, and really will be able, 5G will be able to enable all of these amazing technology advancements that we've seen in the previous presentations. So, you know, what is it about 5G standalone that makes it a game changer? So obviously it's the high bandwidth is one of the technology advancements that we've seen. It provides significantly higher data rates. Also, the network slicing capability allows us to slice out different types of SLA quality service types for different customer segments, vehicles in this case. Also, of course, low latency with technology, also massive machine type communications designed for a massive number of devices per square kilometer, up to 1 million, making it ideal for proliferation of IoT devices within vehicles across smart city and infrastructure and connected cars environments. Also enhanced security, of course, as we've seen, It introduces robust security protocols, which is critical for protecting our sensitive vehicle data and preventing cyber attacks as well. So it really is a game changer. As 5G SA, as we move towards the SDVs, the software-defined vehicles, and the automobiles gradually turn to moving electronic devices, and connectivity, of course, plays a key role in this SDV concept. So the use case is high real-time, high availability, reliability connectivity, of course. These features will improve safety, reduce our costs, and enhance our driving experience. And with a multitude of features will be available from diagnostics and predictive maintenance, of course, fleet management, theft prevention, vehicle V2X, emergency services, even usage-based insurance, support, infotainment, autonomous vehicles, payment solutions. So things are really starting to change, but we do need 5G connectivity ubiquitously around the world, and also roaming. So there'll be real-time decision with all the apps to be special features to be added to the car. Latency become increasingly important. Of course, a good example would be adding ChatGPT to the in-car assistance system with some major car which major car manufacturers are already working on. Apart from voice assistance, it can improve path planning, positioning, interaction with in-vehicle infotainment systems, reduce driver distraction, even significantly contribute to advanced autonomous driving features, including, of course, all the V2X, V2V, VTI, and so forth. So this would all require, though, high bandwidth, or at least low latency, and in some cases also high bandwidth, of course. So latency-sensitive applications and car connectivity are well served with 5G standalones, low latency, and high bandwidth capabilities. So in order to enable all of this, vehicles need continuous high-quality connectivity across borders. The continuous coverage is critical. So losing connectivity is obviously not an option. You could even reduce the level of security and safety, of course. So even though we've seen cellular connectivity is the best option for vehicles for its ubiquitous reach and global viability, even supplemented by satellite, as we heard from Shariq. Each operator's network inevitably has weak spots, and that's why eSIM profiles and automated remote eSIM provisioning, of course, is crucial to this ubiquitous connectivity for cars, as is satellite connectivity as well later on. So sometimes, rather than using a local IMSI, in particular in visitor countries, it's better to use a roaming profile, because a roaming IMSI will have access should have access to all of the networks in that country. So there are certain pieces that need to come together to enable ubiquitous connectivity for cars. Now, of course, there's also the compliancy and regulations. Depending on regulations, there can be different types of localization that are required in each different market or different country, including IP localization. So that means the traffic needs to stay in that country. It can also be a soft localization, meaning the IMSI needs to be from a local operator, or it can be full localization where the IMSI profile and the data needs to stay in country. So there are also some compliance regulations that connectivity providers need to be aware of and take into consideration. So the ecosystem, and I've tried to map out the ecosystem here. It's perhaps not complete and probably not accurate either, but collaboration is key, of course, between these different ecosystem players. So the connected car connectivity providers are building these intelligent and flexible cellular connectivity solutions, primarily driven by the eSIM technology and multi-IMSI capabilities, which are allowing for dynamic network switching, optimized performance, and relying on both on roaming agreements and leveraging, of course, also local network profiles where necessary. So with eSIM and remote eSIM provisioning, these technologies are real game changers. So a single eSIM can have a primary, a multi-IMSI profile that offers wide coverage globally, and also offers remote download of entirely new local profiles if needed for specific regions for regulatory compliance, as we saw before. So a roaming IMSI should be able to offer localized data breakout as well. So that should also be possible. Otherwise, as in roaming, data is routed back home. So otherwise latency could be higher, which is not a good option and can lead to bad user experience. So a roaming IMSI really needs to have localized data breakout. So, connected vehicles, they need to have seamless global coverage, cost efficiency, enhanced performance, future-proofing, simplified logistics. The MNOs have the cellular coverage. They have local connectivity and they have roaming. The roaming service providers, they are the underlying sort of fabric which sort of brings this all together, making the roaming work and facilitates the integration between the mobile operators and the connectivity service providers and the connectivity providers. Then there are the cloud providers, of course, providing computing and edge. They'll play an important role in the ecosystem here, and also naturally the developers will be developing these amazing solutions, which we've seen a few of just in the previous presentations. And of course, the OEMs, the car makers, are bringing this all together and integrating all this technology into the cars. So what is ComPhone doing? We're a roaming service provider, and we're motivating the operators to launch 5G standalone. Of course, the operators, this is key. The operators need to launch 5G standalone networks. They are doing this now gradually. It's very important that they improve here and roll out 5G standalone networks. They have their own challenges, and that's why it's taking time. But we're all pushing that this happens, and this will be, of course, the driver for vehicle ubiquitous connectivity for vehicles. So roaming service providers are also integrating the connectivity providers with the MNOs, so that the connectivity providers have these full global connectivity solutions based on individual mobile operators' coverage, and we're also working with the connectivity providers to establish geo-distributed packet gateways and UPFs, so that the data traffic that the users in the cars generate can be accessed locally and don't have to go back home in a roaming scenario. So that will reduce latency and increase user experience. So these are the things that are happening, that as the ecosystem participants need to work on and of course are working on. So, and also finally, there are monetization opportunities, of course, for the car makers with premium connectivity services, subscription-based services, advanced navigation, remote diagnostics, vehicle health checks, providing access to new features, performance enhancements via OTA, in-car entertainment features like streaming services and games and so forth. There's also data monetization, of course, with insurance data that can be passed on to insurance companies, predictive maintenance, data sharing, and there's also partnerships in the ecosystem, in-car commerce, of course, V2X and data sharing partnerships. So there are monetization opportunities for the car makers here. So it's exciting times. We just need 5G standalone connectivity ubiquitously with the roaming, of course, as well. And then we'll be able to enable all these fantastic services that we've seen in the previous presentations. And that's all from me.
Awesome. Thank you, Derek. Appreciate that. Let me introduce our next speaker, Furkan Hanilsi from Bursa, Turkey, to present on from SDV to intelligent connectivity, enabling software-defined vehicle functions through telematics and 5G. Over to you.
Thank you, Kanish. Hello everyone, I'm delighted to be here. I'm a software engineer at Kasan Automotive, working as an autonomous driving software engineer. Today, I want to share our perspective on how software-defined vehicles and 5G connectivity are transforming public transformation. What we are witnessing today is not just an evolution, it's a complete paradigm shift. Traditional vehicles with 150 distributed ECUs are giving way to centralized computing platforms. 5G networks are enabling real-time decision making, and autonomous buses are becoming reality on our roads. Let me walk you throughout this transformation and what it means for our industry. The numbers tell a compelling story. The software-defined vehicles market is projected to grow from $345 billion in 2024 to 1.77 trillion by 2034. That's a nearly 70% compound annual growth rate. But more importantly, this represents a fundamental shift in how we design, build, and operate vehicles. In our autonomous bus operations, we're seeing data volumes explode from 24 gigabytes per day per vehicle to an expected 1 terabyte by 2030. This isn't just about storage. It's about real-time processing, edge computing, and intelligent decision making. As you can see, here's a dramatic change. We're implementing traditional buses have 150 separate ECUs. That's 150 individual computers, each doing one specific task. In our new SDV architecture, we have consolidated this to just 3 to 7 powerful domain controllers. Think about the implications. Instead of 150 separate systems that can talk to each other efficiently, we now have undefined platforms sharing data in real time. Network speed jumps from 1 megabit per second CAN bus to 10 gigabit Ethernet. Processing power increases by 10,000 times, but the real game changer is over-the-air updates. Previously, adding new features meant hardware replacement. Now we can deploy a new autonomous driving capabilities, safety features, or passenger comfort systems throughout software. Our SDV architecture has 3 critical layers. The bottom layer handles real-time safety critical functions, braking, steering, door control with ASIL D functional safety certifications. The middle layer provides vehicle services and communication protocols. The top layer runs applications, passenger information systems, fleet management, predictive maintenance. The architecture enables something revolutionary, the convergence with 5G networks. 5G changed everything for autonomous vehicles. We've reduced end-to-end latency from 40 and 60 milliseconds to 4G to under 5 milliseconds in 5G. That's a 10 times improvement for autonomous buses making split-second safety decisions. This matters enormously. Bandwidth increases 20-fold to 10 gigabits per second. Connecting density supports 1 million devices per square kilometer, but the most important feature for us is network slicing. Network slicing allows us to create dedicated miniature networks for different functions. Our emergency braking systems gets an ultra reliable low latency slice with nearly 90% reliability. HD map updates use a high bandwidth slice sensor. Telemetry use a massive IoT slice optimized for low power. This isn't theoretical. We're deploying buses with multi-axis edge computing integration. Processing happens locally at base stations with under 10 milliseconds round trip times. Critical decisions don't depend on distant cloud service. Vehicle to everything communication is transforming traffic management. Our buses communicate directly with traffic signals for priority green lights. They share sensors data with other vehicles to improve everyone perception. They coordinate with infrastructure for optimal route planning. The latest 5G release 17 standards enable sensors sharing between vehicles. When our bus detects an obstacle, other vehicles in the area receive that information instantly. This creates a collective intelligence network. Of course, this level of connectivity demands robust security. Security isn't an optional, it's a legally maintained. Some regulations such R155 and R156 effective since 2024 require comprehensive security, cybersecurity management systems and software update management systems for all new vehicles models in Europe. We implemented ISO 2143 and for cybersecurity engineering throughout the vehicle life cycle. This means threat modeling from the design phase, secure coding practices, penetration testing, and continuous monitoring throughout the vehicle's operational life. Over-the-air updates require military-grade security. We use AES 256 encryption and hardware security modules. Every update is cryptographically signed and verified. If an update fails, the system automatically rolls back to previous working state. Our security architecture has 4 layers: hardware security with TPM modules, system level isolation with hypervisors, application security with code signing, and data protection with end-to-end encryption. This security foundation enables our most advanced application level 4 autonomous buses. Our level 4 autonomous buses operate without human drivers in defined operational domains. They use LiDAR, radar, cameras, and GPS with centimeter level accuracy. But breakthrough is the integration with 5G edge computing for real-time decision making. When our AI perceives a complex scenario, perhaps a child chasing a ball near a bus stop, the system processes this in under 100 milliseconds. Local edge computing provides additional processing power for complex scenarios. If needed, human operator can intervene remotely throughout 5G connections. Fleet operation transforms with intelligent connectivity. Our central operations centers monitors every bus in real time. Predictive maintenance algorithms analyze sensors data to predict component failures 30% more accuracy than traditional schedules. Dynamic route optimizations uses real-time traffic data, weather conditions, and passenger demand to adjust routes automatically. Energy management systems optimize battery usage and charging schedules. We have achieved 25% energy saving throughout AI-driven HVAC and route optimization. Passenger safety systems include emergency communication, automated wheelchair accessibility, and AI-powered monitoring for social distancing and safety components. Looking at the roadmap becomes even more exciting. The next 5 years bring 5G advanced with sub 1 milliseconds latency, edge AI processors with 1000 TOPC capability, and the early deployment of 6G technologies, quantum safe cryptography will protect against future quantum computing threats. Large language models will enable natural language vehicle control. Federated learning will allow our bus fleet to share knowledge while preserving privacy. Digital twins will enable virtual testing and optimization.
Furkan, your time is over. Would you mind to quickly wrap up?
Okay, thank you. Last one, thank you for attention. I'm happy to take your question about our experience. Please feel free to reach out to me for any question. Thank you.
Furkan, this is so brilliant, fantastic, amazing information. Thank you so much. I really appreciate that. Let me introduce our next speaker, Aditi Bala from Berlin, Germany, to present in-cabin interactive system. Over to you.
Hi, Ganesh. Thank you so much for inviting me to this talk, and I'm sharing my screen. Let me know when you see it.
Yes.
Okay, perfect. So today I will be talking about human-machine interaction for in-cabin, so particularly vehicular in-cabin. So I think Ganesh has also touched on it during his talk a little bit, and I will dive more in depth what it is. So basically coming first to what exactly is human-machine interaction. So it is a multidisciplinary field that brings together elements of robotics, artificial intelligence, and human-computer interaction. It basically refers to the communication between humans and machines and how we basically give input and receive feedback from these machines. And coming to basically what is HMI in vehicle, particularly for in-cabin. So basically it plays a very crucial role in how drivers and passengers interact with these key in-cabin systems. So the domain of interaction, it involves study of sensation, perception, information exchange, inference, and decision making. So as you can see, it's very complex. And some of the examples are infotainment, navigation, climate controls, and ADAS. So the traditional vehicle HMI, I guess most of us are very much familiar with them. They included basic physical controls and displays, and they typically consisted of mechanical dials and switches for checking speed, engine temperature, and modifying basic media controls. But with increasing automation within the vehicles, the modern HMI doesn't just perform basic function, they also work at different levels of automation, bridging basically the trust and situational awareness, as you can see from the image, the modern vehicle interface. So in order to do this, basically the HMI, it relies on multimodal inputs from various sensors in the vehicle, like touchscreen, voice commands, gestures, and even tracking system. The idea here is to basically prioritize safety, comfort, and seamless user experience. And basically, finally, these HMI systems are becoming really adaptive, responding to the driver in real time, whether it's the stress, fatigue, or attention level, so that the car can become more safe and comfortable. So with this foundation in mind, I would like to dive a little bit deeper how we come from the simple knobs and switches to these intelligent responsive systems. So firstly, in 1990s, the vehicles, they primarily have these mechanical knobs, and while they did the job of controlling radio, climate, and warning indicators very well, they were not adaptive or intuitive. So in 2000s, we basically started seeing more digital integration with LCD screens and early infotainment systems. And the major shift came in the automotive industry in 2010, where touchscreen became mainstream, and even voice assistants have started making their go in the vehicle, with gesture control also in some premium models. And HMI has become more centralized, with multiple functions housed in a single interface. And coming to the more recent one, and basically which is laying foundation towards the future, the more recent one, they are fully digital, and they support multimodal interactions like touch, voice, gesture, gaze tracking, and these systems are also capable of learning driver preferences. They are able to reduce distractions so as to avoid accidents, and they are also able to deliver more personalized experience to increase the comfort of the driver. So looking ahead in the future, how the HMI will basically look, it will be more intelligent because we are moving towards autonomous vehicles. So the in-cabin also has to change according to it. So and this change is not sudden, it will be gradual. So basically these HMIs have to also bridge various levels of automation from 0 to 5. And therefore, we are moving towards more emotion-aware and context-aware co-pilots or dashboards, you can say. I will show it in my next slide how the future will look like, which sounds really promising, I hope. So in future, we will have HMIs which will be able to basically do emotion and activity-aware empathetic interactions. So it will be able to detect driver stress, fatigue, and give dynamic and empathetic outputs. HMIs will not only just act as plain dashboards anymore, they will be AI co-pilots, or you can say virtual assistants, which will basically anticipate drivers' need and will be able to do context-aware and conversational conversational tasks, so that it can reduce drivers' cognitive load and also help build driver trust in the autonomous vehicles. And finally, the HMI will become fully adaptive, and the interfaces will learn from driver behavior and will become more personalized. So yeah, all these advancements push HMI closer to becoming more intelligent in real time. But how do these advancements ensure that user experience remains safe, intuitive, and human-centric? So as you can see from this image, one of the essential principles is minimizing drivers' cognitive load when it comes to these autonomous vehicles. So the information should be delivered clearly without overwhelming the user or requiring too much attention, as seen in this image, where the command is very personalized, context aware, so as to basically minimize any distraction. Secondly, from the shift of market shift from manual driving to fully autonomous driving, HMI must recognize the level at which the vehicle is working and should be able to support at this level of automation. Then thirdly, it should be able to enhance comfort by learning drivers' habits. So basically should become more personalized, like preferred temperature, music, or interaction mode that the driver enjoys in an autonomous vehicle. And finally, it should be able to interact at different level of modality to include inclusivity and flexibility, because one size never fits all. So now how will basically automotive industry deliver such kind of an intuitive and adaptive experience in cabin? So it all starts with a lot of sensors inside the car, which we already see currently. So these sensors include like visual sensors, driving cameras, or audio sensors like microphone, environmental sensors for temperature or light, and haptic sensors such as the one on steering wheels or on belt, and physiological sensors like monitoring heart rate or stress indicators. This data basically in itself is not so useful, so it will be converted into actionable information like gaze, facial expression, body postures, heart rate, skin conductance, and which will then basically go into an AI system to get distraction detection, emotion detection, medical emergency detection, drunk driving detection. So basically a lot of detection and perception, as I said. And these behaviors will then be turned into interactive actions, such as driving alert, system adaptation like mood-based music, empathetic assistance like engaging conversations, and emergency response like automatic calling in case of emergency. So yeah, the car is, as you can see, becoming a lot more responsive, intelligent, and human aware. Some real world examples we can already see around us. First one being Tesla with its minimalistic approach, where they have basically reduced all the physical buttons and it works with voice commands. Moving on with the Mercedes with their augmented reality HMI, and it offers head-up displays and also the Hey Mercedes voice assistant, so as to make it more so as to make the interface more interactive and conversational. And finally, with BMW taking over the different approach of traditional control with modern input. So they have this iDrive system, which basically has gesture and voice input, and it is ideal for drivers who prefer tactile feedback while in motion. So you see each brand tackles HMI differently based on their design and user base for the future autonomous vehicles. But there it comes with a lot of challenges of itself. So while these HMI solutions are impressive, the first and foremost challenge is, of course, the voice assistant limitations, that they struggle with cabin noise, and they also misinterpret the phrasing, which can become really frustrating, which we've already seen with our phones and Siris. The second is this multimodal systems, because the thing is, when you give multimodal signals, the system might get confused, and the conflicting overlapping signals are difficult to interpret in real time. Another one is basically overloading the interface with a lot of information, which can become increasingly distractive and not and will basically be counterintuitive to the task of reducing the distraction in cabin. And finally, of course, the major challenge is seamlessly making it available across different languages, cultures, and driver behavior, and it comes with a lot of development cost. So basically, yeah, while HMI has enormous potential, there are a lot of challenges we have to tackle in the autonomous industry to reach a place where we can say we have fully autonomous outside and inside vehicle systems. But it also comes with a lot of regulatory responsibilities. As you can see, there are a lot of sensors involved and real human involved. So first and foremost is that we, as autonomous industry, should comply with regulations that limit driver distraction. So the dashboard should not increase the risk of being distractive, and there are guidelines from NHTSA and UNIS on these. And also the modern HMIs, as they use a lot of personal data, the manufacturers should not misuse or expose these data, so there should be protection laws. Thirdly, because there are always on cameras and biosensors inside the vehicle, so we really have to ask ourselves who control this data and how is this data used. So it is important to balance personalization here with transparency and user autonomy. And finally, we have the industry standards to manage the risk. So we have ISO industry standards 26262 and 21448 for safety and intended functions, which basically deals with complexity of HMI systems. I know I have been really quick because I wanted to conclude a very big topic within 10 minutes. But in conclusion, I would say I hopefully was able to deliver the idea what is basically in-cabin HMI, which is basically a very crucial element in the upcoming autonomous vehicles. And it is no longer just about controlling a radio or setting temperature. It is basically will define now how we communicate with these increasingly intelligent machines and how they will respond to us. More importantly, these HMIs, they not just deal with one discipline, they touch a lot of disciplines like psychology, artificial intelligence, hardware sensors, interface designs, and also, of course, the communication technology that you need with these models like V2X. And finally, these vehicles, as they continue to evolve and become more smart, you can say, more intelligent, these will be the gateway to trust, so that the user will be able to trust the upcoming fully autonomous vehicle, because as I said, it is not a jump from 0 to 5. It comes in phases, and the driver or the end user should be able to trust that. So yeah, I hope I was able to give you a brief idea in a very quick overview of what is human-machine interaction in in-cabin, vehicular in-cabin, and how it is going to change the autonomous industry completely. Thank you so much.
Thank you, Aditi. Appreciate that. Let me introduce our next speaker, Dominic Burden from Garching, Germany, to present software-defined vehicles and 5G, the path to connected mobility ecosystems.
Thank you, Ganesh. Thank you for having me and the opportunity to also present a glance of my research and also my area of interest. Do you see the right screen and I am audible?
Yes, sir.
Okay. Then let's get it started. So premium vehicles include today up to 150 million lines of code. By 2030, it is expected to reach already 300 million lines of code. A Boeing 787 Dreamliner contains 14 million lines of code. Means today's premium vehicle, 150 million lines of code versus 14 million lines of code. So when I first read about it, for me it was somehow not thinkable. A quick glance on my agenda, background, SDV driving forces, the key enablers for 5G, and the path. Why is everyone talking about software-defined vehicles? I put together some fundamental challenges in the automotive industry, which are tackling or triggering this evolution. One thing is that it seems the car peak, the worldwide car peak, is behind us. The yearly car sales are stagnating. We did not reach the pre-corona niveau so far. So this is one point. Rising vehicle costs. We all are aware about the technology, the complexity, increasing control units per vehicle, material costs, now the discussions about the tolls with US, with China, and the world economy. Post-SOP support means not changing the car, not changing the hardware, but updating the car that it feels like it's a new car with the functionalities and the features. User expectations, those were also changing. We are now in a time of the digital natives. They have other expectations, like maybe me and some older people which are more hardware driven. So what engine is in the car, which which performance, which tires, which design, so more on the hardware focused. Then the cost of this transformation from hardware driven development to a software driven development. Then the technology and architectural complexity. I talked about increased functionalities. You need electronic control units to compute the data. And here we are talking, when we are talking about a premium vehicle, 150 million lines of code, we are talking about 150 ECUs in a car. So in this limited space of a car, you need to cope 150 ECUs, all the harnessing, all the space for the ECUs itself. And this is also driving the costs and the complexity. Not to forget also about the cultural and organizational changes. Big corporates need to incorporate this strategy, this change, because they are not ready for it. You need to think fast, you need to think smart to cope with the SDV-driven or software-driven car development. Enhanced customer experience. We heard it before. So digital natives are expecting something else. And new revenue streams. Of course, corporates and OEMs and other industry participants are interested into revenue, and with that coming with an SDV along new revenue streams. The SDV driving forces. You might heard about the CASE paradigm. CASE was established 2016 from Mercedes-Benz, and those are the main strategic pillars of Mercedes. Maybe the weighting is now shifting a bit also about the issues with electronic vehicles in Germany, in Europe, but nevertheless, I think they are still valid. It's about connected, autonomous, shared, and electric. So in total, the CASE paradigm, user expectations, rising vehicle complexity and costs, post-SOP support, and the centralized vehicle architecture. The key enablers of the 5G. I heard it also before, the ultra low latency. This enables real-time performance, vehicle to everything, V2X communication for safety, for automation, and of course for autonomous driving in the future. Edge computing, all those data needs to be computed, and there's also a very strong backend necessary. New business models comes along with the new revenue streams and the connected mobility ecosystems. To foster collaborations between OEMs, tech firms, telecommunication firms, software providers, cities, everything what is in this ecosystem needs to be incorporated and is the backbone of software-defined vehicles, and I would say also of autonomous driving. Then how does the path look like? The path towards software-defined vehicle. During my research, I found this methodology from Dr. Moritz Neukirchner from Elektrobit, which is kind of impressive, this comparison. He is saying we can cluster SDV into 6 levels, 0 to 5, like the autonomous driving levels. And under the umbrella of 5G, we could say, okay, we could include level 2 regarding the over-the-air updates. But if you park in your garage your car, the over-the-air update can be done also over the night, so you don't have any timing concerns here. I would say, so therefore for me, it's SLE level 3 to 5, where 5G kicks in. And with this, I also want to conclude my presentation. I'm thinking we need to go step by step in the right direction of software-defined vehicles, build the backbone, build the ecosystem, go into collaborations with partners from different industries, have a good network to get network effects within the ecosystem, and then pave the way towards SDV and autonomous driving. That's it from my side. Thank you very much.
Awesome. Thank you, Dominic. Appreciate that. Let me introduce our next speaker, Maxime Flamand from Brussels, Belgium, to present on driving the future of mobility, connected cars roadmap.
Hello from my side, Maxime Flamand here. I'm just setting this up. You should be able to see my screen now.
Yes.
Yeah, great. So yes, thank you very much, Ganesh, for the invitation. I'm very happy to present here the 5G Automotive Association. The 5G Automotive Association is a place where telco and automotive are meeting, and our main target is to work together to develop end-to-end solutions for future connected vehicle services. We were created about 9 years ago by 8 founding companies, which are displayed here on the bottom left. Since then, we grew up to about 115, 120 members. We represent truly a global cross-industry association, so that means almost all vehicle manufacturers are represented, almost all the global mobile network operators, as well as the smartphone vendors. We have, of course, also the supply chain from the vehicle manufacturers, also the supply chain from the mobile network operators, as well as the IT solution vendors, such as the chipset manufacturers. When we talk about C-V2X, we often try to divide or show complementary communication modes. So the previous speakers spoke either of the reliance or the use of the mobile network, 4G, 5G networks for the connected vehicles. Other speakers talk about the short-range communication using the 5.9 gigahertz spectrum, which is allocated around the world. And we also saw, for example, with Sharik talking about the non-terrestrial network. And so I'll dive into this a little bit more in the next slides. But before that, I wanted to say that one of the core of our activities within 5G Automotive Association is to put together perspective, global market perspectives in terms of what are we expecting in the next few years in terms of connected automated driving. What are the use cases that are the most attractive to the industry, and how we are going to address them from a standardization point of view, but also from a policy point of view in terms of full deployment. So in a nutshell, our mission is to make things happen in terms of connected vehicles, not only just connecting the vehicles for cat videos or infotainment, but also making sure that these contribute to safety on the road and traffic efficiency. Now, the roadmap that you see here is our simplified roadmap. Every second year, we update this with more details. The last update was done in December last year, 2024. This gives more details on what we expect when in on a time frame. Some of them are obviously looking at the past. So what has been deployed already in terms of services, local hazard traffic information, data collection and sharing, even intersection safety, if we look at China, has been now introduced. But on the right side, starting from 2025, we have other use cases. Many of them are related to automated driving and automated functions. And so I will spend a little part of this presentation at the end to cover what are the current challenges. But one thing that is should be also noted is the introduction of non-terrestrial network services here in gray, which are now in the 2-year perspective in the on different at the global level in different vehicle manufacturers. So at 5GA, with all the members, we define a work program. This is the work program 2025, looking at different aspects. We implement these into different work items, and I will illustrate only 3 of these topics. One, I wanted to talk about non-terrestrial network and the integration within the current frameworks, but also the future path. And the NTN is, and to not, sorry about the confusion here, a little bit more diving into the NTN roadmap. Now you have seen 2 roadmaps before, that's our global roadmaps, but now looking at more service aspects in terms of the non-terrestrial network. I couldn't go into the details of how this roadmap was done, but one of the things that should be noted is that we have NB-IoT currently available into geostationary and LEO that can serve for a batch of services that are narrowband services with less than a few hundred kilobits per second. We are looking at another batch of services that are a bit wider band services being served with LEO 5G NR potentially, and then looking at further wider band and broadband services that are more in the perspective of 2030. And in terms of implementation, we have been working with 3GPP in order to make sure that these are reflected in their standards. The implementations for the narrowband and the wideband services are related to FR1 exploitation, still using low complexity and even reusing existing terrestrial antennas, whereas the broadband services will have to be served in the FR2 frequency spectrum, where directional phased array antennas are needed, and perhaps higher complexity for integrating these kind of antennas in the systems. Now, looking at a few weeks ago, we had the pleasure to welcome some of our members in Paris, 15th of May, to demonstrate this NTN technology based on 3GPP. Of course, here we are still talking about geostationary and the IoT kind of systems, but we were very happy to have different vehicle manufacturers showcasing the technology in cars, on the roads, among them BMW and Stellantis, but we had also tier 1 vendors like Harman, LG, and as well some chipset vendors like Qualcomm and MediaTek. So very happy to see this supply chain getting ready to get NTN into the cars. The second part that I wanted to talk about is the LTV2X Direct and 5G V2X Direct. Now we are getting ready within we are getting within different markets to deploy LTE V2X direct, so using the 5.9 gigahertz for V2V communication. In China, it has been now done for some time with 20 megahertz that were allocated in 2020. We had FCC ruling giving LTE V2X as a technology of choice in 30 megahertz, or actually 20 megahertz will be exploited at this stage. Korea also 20 megahertz technology of choice. Japan, we are still waiting for some considerations in terms of allocating the frequency band, which is still used by other systems. And India has shown their interest to now join the wagon or the train. In all these, we see common aspects, alignment between the different ministries on the deployment of V2X, synergies between network and direct communication, clear V2X deployment plans, spectrum allocation for V2X direct, and OEM commitment, inclusion into NCAP. Now, when we look at Europe, we are not there yet. There is DSRC, as we saw from Malik, I think, earlier. DSRC is still in the air. The road operators are pushing for DSRC, whereas only Volkswagen has been implementing this in their cars. We, as 5G, we are saying that the DSRC is not enough, and we want to make sure that part of the bands is being used by the 5G V2X direct communication. And in this respect, we have done 5G V2X direct demonstrations. So we made an open statement in 2023. We had first demonstration in Berlin of 5G V2X with static demonstrations inside Audi and BMW. And we then further now last month in Paris made a on-road traffic, live traffic demonstration of 5G V2X. So very proud to see that this is happening at this stage. Now the final 3 slides, there is 3 examples that I wanted to show, are related to the automated functions. So on the right top side of our roadmap, one of the low-hanging fruits with regards to automation is automated vehicle marshalling. It unlocks something very important, which is the motion control. Motion control has been standardized by ETSI and in different also parts of the world. However, there is still some divergence on how to use it, how to use motion control. There are 4 protocols that have been standardized. We are trying to, with the industry, make sure that we converge toward 1 or 2 maximum protocols, so that we make things happen. At the moment, this is done mostly on what we could call campus areas, so mainly production sites. But if we converge towards a few motion control protocols, it may then lead to the possibility to use this same technology for automated valet parking and beyond, of course. Now, the second example that I want to show in terms of the introduction of automation inside the V2X, or rather the opposite, V2X inside the automation, is with regards to the NCAP introduction. There are some tests, if we look at your NCAP, that are mostly targeting awareness information. But if we look at what's happening in China, we are looking at more and more time-critical kind of warnings, to the extent that this may then be included in interventions in the vehicle. So that we are often talking about soft interventions in the vehicles with V2X. That means that ahead of a potential danger, before the sensors have detected anything, there is a soft actuation in the car, which can lead, for example, to change of speed, but avoiding hard maneuvers. So And then the third example that I wanted to show about V2X in ADAS is the example of collection perception message, which is called SDSM or SSM in China and US. And we see two different challenges. One which is more the V2V aspects. How do we, for example, give information about a congested lane and the space between the cars to an emerging vehicle that comes into this highway? What are the level of trust that is needed, and what are the handshakes that are needed between the different vehicles, so that we then allow this at the scale and in the industry. We have seen that many times in proof of concept, but there are still some challenges to break before we get this in the cars at scale. The second example of V2X into ADAS related to collection perception messages is the inclusion of the information coming from sensors on the roadside. This information may, for example, detect vulnerable road user or pedestrian here and notify the oncoming cars that has not seen the pedestrian about the danger, and even lead to either a soft intervention, but even a hard intervention when or prepare the hard intervention when the sensor also detects the danger. So all this to say that the 5GA has been working mostly on this roadmap and is tackling all the aspects of the roadmap from standardization policy, but also introduction of the vehicles. Thanks.
Thank you, Maxime. That was fantastic. I really appreciate for your presentation. Great stuff. Dear speakers, please do switch on your camera. Let's do a quick 10 minutes or so to discuss a question that I've posed earlier in the beginning of this conference. I mean, let me share my 2 cents of thoughts about what's going on around the global. Maybe I'm wrong, but what I realized that most of these automotive car makers they do work closely with the government, and they are trying to make sure that they can sell those cars locally, and also exporting to some of the specific countries. There's a lot of geopolitical issues are going on. Tariffs is another area as well. So, but when it comes to the technology itself, I realized that a lot of these car makers are trying to work within the autonomy of the car rather than want to connect to the external infrastructures like the telecom mobile network operators. Not all the countries car makers wants to open up and work or collaborate, partnering with the other parties as an ecosystem. Right, that's a big challenge here. So coming to the question is how telecoms are reshaping the mobilities. The mobile network operators together with the telecom vendors are really going all out together with the car makers. They are working closely with the regulatory bodies? Do they work closely with the government in terms of creating the right policies? Anyone wants to share?
Maybe I would like to propose one discussion, because I totally agree that it's like a geopolitical situation, that there is many players trying to push the standards, and I think that is not like a short run, but it's like a marathon. And I believe that the country that has your own regulation and your own market ready, they will bring this for the other countries. And this maybe it's exactly my original question for so many experts here: which country that is leading this run at this moment? I see as China is leading because they have a lot of investment, and they are the first one to introduce the new necessary legislations. But maybe it's not the best opinion. Maybe there is another opinion of someone that say no, maybe there is another country that is leading this race at this moment. But again, it's my opinion, just to finish. I think that we are being triggered by the China speed at these policies and infrastructure investment for the future.
Maybe.
Okay. Okay. So I will yes. So I will talk about as you mentioned, China is leading. Yeah, this is all about the investment. Like China is investing big money in order to enable vehicle connectivity and to lead autonomous vehicles. But as Ganesh asked about how telecom is reshaping the mobility. So here it's we have to follow some standard in order to ensure the compatibility. If we just look at our cell phones that we are using now, the technology that we are using for the communication, so we have a unified standard. So same wise, there are many groups that are playing part 5G AA and 3GPP, and there are many industries that have joined such groups, and they are participating in order to promote and to enable V2V connectivity and to support V2X communications. And also many presenters have talked about for the autonomous vehicles, and we cannot have fully autonomous vehicles without the connected vehicles. So in order to have connected vehicles, we need to rely on the technology, how we can communicate. And for the communication perspective, we need to have some regulations about how we can use the frequency, because we have some resource scarcity, or we have limited resources. And if we talk about FCC, that has gone the rules that we have 30 megahertz for V2X communications, and those 30 megahertz is very, very limited. If we talk about 5 years back, we had 75 megahertz spectrum that was for ITS, including DSRC and for cellular technology. But the good thing is they have recognized the cellular technology as a unified standard, but they just have allocated 30 megahertz. And our goal is how we can ensure how we can utilize that spectrum efficiently, those 30 megahertz. And I see that I have followed the updates from many industries and companies that are the member of 5G AA and also participating in the 3GPP meetings as well. They are working towards both V2X communications, and they have launched, some of the industries have launched the chipset for the V2X communications, and there are many companies. But one question that comes always into my mind, how we can scale this technology, because now we are testing with just few number of vehicles, but in order to support the connectivity all around with the connected vehicles, we need to ensure how we can scale this technology. And to scale this technology, we need to develop some algorithms, or we have to work on such algorithms, how we can control the channel congestion, how we can avoid resource conflict as well. So from
Thank
this
you,
platform,
Dr. Madi.
I just like to convey my message to those industry key players. Maybe they have to look for the channel congestion aspect as well, rather than just making the vehicles to communicate. We need to talk about how we can ensure to utilize the resources, that spectrum efficiently, so that we can scale this technology.
Thank you. Maxim?
Yeah, so for me, I mean, I clearly go along with Malik here. We always try to advocate for a combination of technologies that are embedded in the cars. Here, I mentioned the usual connectivity to the mobile network, 4G, 5G, and then eventually the use of the V2V aspects, the short-range communication, directly between different vehicles or between vehicle and infrastructure. One does not go without the other. In short term, if we have to make sure that we exploit to the full extent the potential of connecting to the mobile network, in the longer term, while the penetration of this kind of technology is increasing in the cars, then you can start making or capitalize on this. But the first percent of vehicles that are going to be equipped is not going to make a big difference in terms of safety, in terms of the short range communication. It's when you reach 10%, 50%, then you really can start counting on this. And that, in a sense, you're going to have to wait, even if all vehicle manufacturers adopt the same technology, you're going to have to wait at least 10 years or 10, 15 years to get to the 50% plus. So in the meanwhile, we have to just use the mobile network to do our best in terms of safety. Thanks.
Fantastic. Dominic?
Yeah, I just want to comment also on this, what Malik and now Maxime mentioned and described. So also during my presentation, I tried to put the focus a bit on the backbone, on the ecosystem, and I think it's indispensable to have V2X and not limited to vehicle. I think we need to think broader, to vehicle to infrastructure, vehicle to city, vehicle to mobile phone of the pedestrians, vehicle to, I don't know, whatever. So really vehicle to everything. And this will pave the way. And the ecosystem, it concludes so many stakeholders. It's not limited to tech firms, telcos, and OEMs. So as said, pedestrians can be also part of the ecosystem. And to go along this path, this is now, I think, the way. Not only one firm needs to pioneer, it's many firms, many providers need to work together to make it happen, to come down the road. As heard also, China is maybe here at the forefront, but especially we here in Europe, we need to dive into this challenge. Otherwise, the others are far behind, far in front of us.
Thank you. Aditi?
Yeah, I just like to add to what Dominic said and also what Maxime has pointed out, that it's not just about like one technology in play, because it's not just V2V or just V2P pedestrian or just V2 infrastructure, because all of them, they use very different kind of communication band. So so it really isn't just about regulatory bandwidth, or when it comes to just like, okay, having one in place, it is more complex than that. And not just that, we really have to also go into the direction of these machine learning models, because as far as the cars go, the vehicles go, you cannot fit all of the machine learning models that we want to deploy inside the vehicle. So either you have to deploy it on a cloud, and then they have to be connected, and they have to be connected in real time or by some offline online mode. So there, I think it really is sort of an important or pivotal role of telecom to define like these sort of standards for different kind of communication. Because as I said, it's not one size fit all, that if it's V2V, we can transfer it to V2X also, and we can transfer it to V2P, because all of them, they basically touch very different sort of use cases and problems. So I think there it is more complex than it's simpler that we just have a discussion about it and come up with just one standard. So I think it will be kind of a marathon, as you mentioned. So it's sort of like we have to come to discussion and make it a marathon.
Thank you. Sharik, you have anything to say?
Yes, thank you, Ganesh. So I was listening carefully, and I'm in line with Maxim, and I think even other participants, what they've mentioned, because personally, and even from the industry, what I see that communication is not only cellular. That means we have short range, we have multiple internal communication inside the car, and even external communication from different interfaces. Today, we see multiple models, but not a unified one. So perhaps there's a need to unify them. Of course, China is leading. That means what about the rest of the world? Perhaps we need a common platform to represent our voice, whether because one car OEM, one tier one chipset manufacturer cannot make it all. That means we require a common voice. For example, like with 5G is one of the platform. Like this, we have other platforms in 3GPP, ETC, but there should be a force and momentum which shall push industry, infrastructure, other participants, ecosystem to fall in line so that we could harvest on one technology and one standard which fits all, rather than each one going its own way, and then we have a not a consensus. And I think this is not the way towards maturity. So that's my 2 cents on this topic.
Thank you. Furkan?
Yeah, just listening.
Do you have anything to share, Furkan?
No.
Okay, all right. How about Derek?
Yeah, no, it's very interesting indeed. Obviously, from a connectivity perspective, vehicles need the underlying 5G connectivity, which I was mentioning before. So, not sure if that can be used for the short range in the long term, for the short range requirements, but certainly as a basis, the 5G connectivity needs to be there, and that's what the industry is working towards. The mobile operators that's been dragging their feet with that. They have their reasons, which I won't get into now, but it's gradually starting to happen. So that's good news for the future of vehicle connectivity, having that 5G standalone connectivity ubiquitous with roaming integrated as well.
With that, thank you so much. I really appreciate for all your participation. To the audience, please do click subscribe button on our YouTube channel. This video will be uploaded on the YouTube in the next couple of hours, and I'll be contacting to each of the speakers via email, and we will be promoting each of the speakers in the next 1 month, and to get a larger reach out audience. Thank you so much. I really appreciate. So have a nice day. Till we meet then. See you.
Thank you,
Thank you,
Kanis.
Kanis.
Thank you, everyone.
Bye-bye.
Bye-bye.